Alright, good morning. We are going to simplify radicals today. So what is a radical? These shapes, these symbols, or we call them prisms, these weird shapes are called radicals, and sometimes there are big things inside radical, big fat things. So simplifying means save as many as guys from prison. So you may have a big number inside, you need to break apart, get powers and get it out. That's what simplify means roughly, but more precisely when you look at, we need to achieve three goals. Simplifying means achieving all these three requirements in a radical. But before going into those terms, I want to first explain one very often used trick or rule, property among radicals that's going to help us simplify them. It's called product or multiplication property. Whenever you have two separate prisms with the same guards, look, n and n, you can combine them into the same prism, same roof. You can collect them under the same roof as long as you multiply a and b and put it next to each other. Okay? So we kinda mostly use this rule backwards. You have two separate numbers or terms, expressions, and you put them under the same roof. Once you multiply them, 3 times 12 is 36. And then you look at simplifying this thing, and 36 is 6 squared, and you see, oh, 2 and 2 match, so this guy has 2 power 2, and you divide by 2, and this turns into 6. Or you can simply jump here to there. What number multiplies itself to 36? And that's 6. Okay? So again, I want to remind you of this rule from the past, 10.1. If you have a prisoner with power m and guard wants n, what does this turn into? This turns into what? Power form. N, m. Alright, looks like we need to go back to that section. You guys having a hard time remembering those rules. Alright, we learned the radical sign here, and then we quickly learned that if the number inside and the guard matches, it drops to just 1, a. But if the number is not sufficient enough, large enough, it's just 1, it turns into 1 over n. Now here comes our main problem. If the number is inside m, the number outside n, it turns into m over n. Okay? Turns into m over n. So that was the rule mostly used. A to the m over n. And what else we may need here? I think this is all we are gonna use. And especially we are gonna try to match these numbers so they can cancel to 1. Okay? We will break a to the m into numbers so they can cancel 1 or multiple whole numbers. Okay? So let me tell you what these three requirements say. You will keep simplifying a radical. So if you just leave answer like this is not simplified, you won't get full credit. And especially in Connect Math, it's gonna say incorrect. Although you did everything right, you multiplied this and combined. This is not being simplified. How do I know that? Because no factor, when you break this number into factors, must have a power greater or equal to. There are two statements here. Greater or equal to. Powers are no good. When I turn 36 into 6 squared, you see they are equal powers. So I need to simplify this. So I see power base 6, prisoner 6 has power equal to the guard, same power. We need to simplify it. Okay? That's what rule number 1 means. I call this the money the prisoner have. No prisoner must have money more than what the guard demands. Guard demands $2, you have $2, so you can simplify it. If you have 3, you can still simplify it. If you have $4, you can still simplify it. No money more than the index money is not over yet. It's not simplified yet. Statement 2. Radicals, these radicals must not have any fractions inside. Such as this example. You see 1/4 under this prison? This fails the condition. This fraction can be further simplified. This has not been simplified yet. We can further simplify it. Why? Because it has a fraction inside. Fraction. That means bad. What is the last one? No radicals must have a denominator which has another radical in it. Look, you have a denominator here, but that denominator has a radical. Right? You see the prison here in the denominator? No denominators must have radicals. So this is again bad. Again, why is the first one bad? Because this prisoner X has $5 and the guard wants $3, so this guy can break prison, can pay off the guard and escape. That's what it means. So this can be simplified, this can be simplified, and this can be simplified further. If you leave your answers like this, it's gonna say incorrect. Mathematically, that's not the final answer. Although you did everything right, algebra is correct, but you did not simplify, so it's incomplete. So that's what we are going to try today. We are going to simplify radicals until no more of these rules are violated. Is it clear again? Again, no big powers, no fraction inside, no radical in the denominators. 3 things. Okay, what is violated here? So we need to simplify this more. It says simplify the radical. I'm wondering what has been violated here, so we need to simplify. What is it?
Would there be a 2 there?
What's that?
Would there be a 2 there?
Yeah, the index is 2. If you don't see anything in the index, that means it's as default 2. So what is the violation?
Yes, that's jail. Prisoner has too much money.
Yeah, this guy is rich, so he can pay off the guard. Okay? He can pay off the guard, but how? Technically, this thing is equal to d to the 5 over 2. Okay? This is, you divide 5 by 2, but no, in simplification, we just don't convert it into power. So again, this is 2. So here is how you need to simplify. I'm wondering how many of these guys can escape, because for each prisoner you need $2 and you have 5. This is what I'm gonna do. 5 means 2 prisoners, and a single prisoner, right? 2, 2, 1. You have 5 D's here. 1, 2, 3, 4, 5 D's. I break it as 2, 2, and 1. And each of these can escape, right? And this guy is locked in. And d square, again, d square can go away, cancel with this. D square will pay off the guard as well. But this guy is poor guy. It doesn't have enough money, $1 only. So there are 2 D's out, but 1 D in. So what happened to monies these each guy have? They paid off and they dropped to $1. 1, okay? The operation is always division, and this is d squared. D is the answer. Okay? Double D means d squared D. This is the long way. I just showed this once. I won't be doing this way. I won't break this 5 D's into group of 2's. This is what I'm gonna do. You're going to do a division, long division you've been doing since first grade, not first grade, maybe third grade. How do you guys divide 5 by 2? How? You put 5 here, right? 2 there. I'm wondering how many prisoners can pay off $2 demand. You have $5. How many times 2 goes into 5? Once. Twice? 3 times? How many times? Twice. 2 times 2 is 4. You put it underneath. 5 take away 4 is 1. You remember this division, right? Okay. So this is called quotient. This is called remainder. It tells you how many D's left inside. This tells you how many D's comes outside. And this is what God demands, and this is how much you have. But the result will be using blue and green. Again, this means how many D's comes out. I see 2, so 2 goes in right here. And this says how many D's left inside is just 1. You don't even need to show 1, okay? So you can just do D to the first D, okay? So basically what you do is divide the number in by the number out. Remainder will be the new power of the D. The quotient, how many times 2 goes into 5, will be the new power of D. Again, this 2 is right here, not here. And this is still index 2. Okay? So let's type this in. D squared, you saved 2 of the prisoners, but there is still 1 more left. Again, I do the final check this way. Focus on the radical. Do you see any more power greater than or equal to the index? Do you see any power greater than or equal to index? No. $1 is less than $2. We're safe. Do you see any fraction inside? No fraction inside. Do you have any denominator with radicals? No. So this is all 3 requirements check out. Okay? So let's quickly do this question as well. No brainer, same deal. You take $14 and split it in 3 ways. $3 demanded for each prisoner. Let's see how many prisoners can you save with 14 bucks. How many times 3 goes into 14? 4. 4 times 3 is 12. 2 remains. So remainder goes to the top of C. This 2 goes remainder. They remain here forever. And 4, where does 4 go? Out. These are the C's, amount of C's you saved. You saved 4 of them, and the index is still 3, and you're done. Let's check 3 requirements again. Is the new power inside less than the index? Is it less? Yes, it does. Satisfy requirement 1. Do you see any fraction inside? No. Do you see any denominator with radical? No. So this is the most simplified form. C to the 4th cube root or 3rd index radical of C squared. Okay, C to the 4th. How do you make 3rd index cube root? This is how you make it. You use this nth root symbol, okay? And C with a square inside. Alright, you see question number 1 and 2 only involved this. Requirement 1. You had some powers greater than the payoff amount. Now I believe there will be fractions coming up. No, not yet. Still easy questions. Okay. Do you see any fractions? No. We're still good. Yeah, we will start seeing them until after 7. Alright, what's the deal on this question? What is the difference when you compare number 3 to 1 or 2? D to the 5, C to the 14 here. There are 2 types of prisoners. Let's see how many of them you can save for each type. 13. This has $13 and guard wants only $2, so I believe you can save some of the C's. And D's, the other gang, has $12, right? And the guard wants $2, so I believe we can save some of the D's. You just need to compute each case. So I'm starting with 13. 2 goes into 13 6 times, and remainder is 1. That means C to the 6, C to the 1. Do you agree? Look how quickly I did. Divide 13 by 2, it's 6, C to the 6. What is left? Remainder is 1, so C to the first left. Let's do 12 and 6 now. I'm sorry, it's 12 and 2. 12, and you're paying off guard $2 each. How many times 2 goes into 12? Oh, there is something happening for the first time. There is no remainder. That means, what are you going to put above D? Since no D is left, D to the 0 is, what is D to the 0? A number raised to the power 0. 1. It's 1. So you can actually make this disappear. D to the 0 is 1. It disappears. 1 times C is C itself. So where did all those D go then? Where are they now? Yeah, they are just beside C to the 6. So I need to squeeze them in here before the prison. They are out free. So all those D's are now here as with 6 power. How do I know the 6 power? Because this is what I read there. And prisoner is, there is still one prisoner, which is C. C to the 6, D to the 6, radical of C. All right. Next question. Oh, this has no power, right? This has only $1 and the guard wants 2. So I believe we are not going to be able to save anybody here. Look, this is $1, this is 2, so it's already been simplified. Agree? You can't save anybody here. 1 is not divisible by 2. You already have less power than the index. Am I right? Now be careful with numbers. Especially a 2-digit 75, kind of big number. That means you can turn them into powers. So if you see numbers, you need to make sure they cannot be turned into powers. You need to break them until that you get all the powers out of that big number. How do I do that? You need to factor this. Factor. Do you know how 75 factors on top of your head? 355. If you don't know on top of your head, this is what you need to do. It's branching method. Just first find 2 numbers multiplying into 75. Any 2 numbers multiplying into 75. Try calculating. Is it 2 times something? No, 2 times nothing makes 75. Is it 3 times something? Maybe. Divide 75 by 3 and see if you get a number. Do you get a number if you divide 75 by 3? Take a calculator. Yes, which is 25. And then go forward if there is any breaking, further factoring going on. Can you break 3 more? No, so this is luck. So whenever you have a locked number, put it right here. That's one of the factors. Next, continue with this. Can you break 25 more? Yes. 5 and 5. Can I break 5 more? Locked. Locked. Whenever you have locked numbers, you put them in here. And not only break them into simple pieces, also if there is a repetition of numbers, raise them into powers. How do you write 5 double 5 in powers? It's 5 squared. Now take a look at this question. It is 3 times 5 with a power. It's just like this question now. There are two types of inmates here. Prisoner 3 and prisoner 5. However, prisoner 3 is poor. It has only $1. So can you save this guy from this prison? Can 3 breaks out? No. Because guard demands $2. Alright, can 5 break prison though? Yes. Guard wants 2. This is 2. 2 divided by 2 is 1. So 5 comes out as 1. But 3 cannot. So 5 root 3 is the answer for this question. You already knew this. I know some people can figure this out quickly, but like 75 is 3 times 25. 25 has square root 5. I just do it the official way. Mistake-proof way. You don't miss a spot this way. You break all the way, power, raise power, divide the power by the index, etc., etc. 5 root 3 is the answer for number 4. Alright, let's see what's coming up next. This is a combination of number 3 and 4. Let me check what you have in number 3. You had 2 variables, 2 type of variable prison in number 3. In number 4 you had only a number. In number 5 you have a number, variable prisoner. It's combination of 3 types together. Number, variable 1, variable 2. First start with the number and break that number into powers, and this is an easy one, so you can do it right on top of your head. What power 9 can be raised into? 3 with a power square. That's number 9. M already has an invisible power, which is 1. N has power 4. How much is the bailout money? How much money do you need to break prison? 2. So start dividing, please. 2 divided by 2. What is quotient and what is remainder? Nothing remains. And when you divide 2 by 2, you get 1. So 3 to the first comes out as like that. Take this shorter. Okay, next. So this guy came out as 3 to the first here. Because 2 divided by 2 is 1. Can you save M from prison? No, he has no money. It's M to the first stays. Can you save N to the 4 out of prison? Yes. Divide 4 by 2. 2 goes into 4 twice. 0 means N to the 0, N completely comes out. If you have 0 remainder, that means no N remain inside. They are all out. So make them all out. With what power though? That's square. So that's it. 3n squared m is the answer. Got it? Alright. What's the deal with number 6? Look, they're almost identical. Number, variable 1, variable 2. 9mn, 48xy. Pretty much the same thing. Except they just challenge you with uglier index and uglier powers. an uglier number. 9 was smooth, nice number. 48 is not that nice, right? So work on this one. I'll give you a minute. Let's erase the left side so you can kind of get help from here. I'll give you a minute to figure this on your own because there is nothing new you need to know. It's just combine what you learned so far. Alright, first thing I'm gonna do is I want to expose all the powers in 48. Looks like nothing right now, but when you break 48 into numbers, simplest numbers, there are powers coming up, I believe. First, pick two numbers that multiply into 48, any two. 6 and 8. Then break 6. 2 and 3, they are locked, so circle them. How about 8? 4 and 2. 2 is locked, but 4 continues. 4 is another pair of 2's. Wow, okay. So this is quadruple 2's, 1, 2, 3, 4 2's, and a single 3. So that's 2 to the 4th and 3. 2 to the 4th, 3, x to the 7th, y to the 9th. Okay? Now, which one of these powers I can save from this prison? $4 demanded. This guy has exact change, $4. So 4 over 4 is 1. 2 is coming out. 2 to the 4th is coming out as 2 to the 1st. 4 divided by 4 is 1. 2 to the 1st. Does 3 have any money? So this guy is staying, no moving. Does prisoner X have money? Plenty, 7, more than 4. So let's see for how many times 4 goes into 7. It's only once. 4 times 1 is 4. Remaining 3 of the x's remaining. 1 x breaking. So this guy comes out as x to the 1st, and there will be still 3 left over. 3 leftovers. This is escaping 1. 1 x to the 1 escapes. 9. How many times 4 goes into 9? 2 escaping. 4 times 2 is 8. 1 remaining. So y to the 1 remains, but 2 of them escapes, y squared. So let's write this properly. Okay, those who escape are 2x and y squared. Those who are locked inside, no money, is 3x cubed and y. Yep, the right match. Except I missed writing the index. If you miss this writing index, it means 2, so don't forget it if it's not 2, it's 4. Let's type this in. Two x y squared. How do I make 4th index? By this symbol. First put 4 in, arrow key go in, 3x cubed y, just y. Good? Any questions? Alright. The structure of questions changed. There is a magnificent change, major change here. What is that? Fractions introduced. So you are going to deal with this situation now in this question. The situation is, problem is, your radical has a fraction, you need to clear it. You need to get rid of that fraction. Okay. Here's a fraction, guys. If I ask you to get rid of this fraction, what would you do? You simply divide this. I would break 24 into 8 and 3. And I did perform the division by cancellation, and I get, oh, the result is 8. You see, do you see any more fractions? No? That's what you're gonna do here as well. Divide p to the 11th by p to the 7 if possible, if you are lucky enough. And I think you can. Is there a way you can combine these two powers and perform this division? Okay, here is the long way. I want to show you a long way. What's p to the 11 means? How many p is multiplying itself? 11. Yeah, it's gonna take all day, but I can write 11 p's there. Trust me. Right? And how many p's do you have on the bottom? A little short, but still taking time. 7. Kill each one by one. How many left on the top? I ran out from the bottom. It's 4. That's how I do division of powers the primitive, long, tedious way. But if you've been listening to me on Friday, I gave you a shortcut. What was that shortcut formula? Right. P to the 11 minus 7. You subtract the bottom one from the top. I hope you didn't forget that rule. There you go. Subtraction. 11 and 7, subtract 11 minus 7. Okay? So knowing these rules will pay off. Again, if you have two powers, one on the top, one on the bottom, matching bases, like bases, you simply go from here there by subtraction. So are we done? I see no longer fraction. Are we done? What is always the first requirement we need to meet? We must have only powers less than the index inside. Index is 2. This guy is rich, so he can pay off the bail, right? And how do we do that? How many times 2 goes into 4? Twice, etc. No p's left. So this is p with a square, p square. That's it. Okay? So it wasn't that bad, huh? Just subtract the powers and save the prison. The guy with the power, enough power from prison. Alright, it's getting worse though. 2 and 250. First thing we're gonna do is divide. If possible, simplify. Perform this division by cancellation of common factors. Excuse me. Are there any common factors among 2 and 250? Can you cancel any stuff? Like I did 24 and 3. I canceled some stuff, but can you cancel something between 2 and 250?
No.
Yep. We can factor a 2 from 250, and it's 2 times 125. That's great. This is just cube root of 1 and 125. Well, I still see a fraction inside. What can we do? Yeah, turn all these numbers into power, and I know 125 is first 25 times 5, and then 25 is another double 5. These 3 are locked. So this thing is actually cube root of 1 and 5 cubed. Okay? Now same rules earlier applied. This has $3. The guard wants $3. You divide these and save this 5, prisoner 5, from prison. But once this guy is out, he's out, right? Where does he go? Does it go all the way in front like this? 5 with the new power 1. 3 over 3 is 1. Is this the right position it moves? Is it? How to take this out? It comes out. It has $3, and we move it out. No, this is wrong. This 5 cube was in the denominator, so that 5 to the first, when you leave prison, you still need to be in denominator. This guy goes to denominator right here, this location. Okay, what comes to numerator then? If something coming out here, it goes here, but if there is nobody coming out, you can just feel free to put 1 here. If nobody moves out here, it's 1. But there is something moving out, I believe. What is radical of 1, no matter what index it is? Radical of any index, 1 is, what is it? 1. Look, this is a common rule. If you have 1 inside, it's 1. Why? Because 1 raised to power n is itself 1. So if you like, you can put 3 here. 1 cube is 1 itself, so there is no harm to put cube, and cube cancels, and 1 comes out right here. So the real answer here is 1/5. Okay? Basically, you take the cube root of the top terms, you take the cube root of the bottom terms, top goes to the top, bottom goes to the bottom, and that's it. 1/5 is the answer. Alright, here comes the last question. We need to simplify this. And don't worry about these. These are already free guys. They're out of prison. We don't care about them. All you need to care about is who is in prison and save him from prison. 135. How do you bring it up? I need to first see the power, how much this guy has, so I will break it. Can you give me 2 numbers multiplying into 135? 2 numbers multiplying into, no 2 numbers? No, I think there is a pair. 5 and 27. 5 times 20 is 100. 5 times 7 is 35. They make 135. Alright, I know this is locked. How about 27? Can you break 2 numbers multiplying into 27? 3, 9. 3 is locked. 9, how about 9? 3 and 3. Oh, look at this. You have triple 3, single 5. So that means 3 cubed and 5 to the first. So that's 4. Cube root of 3 cubed and 5 to the first. Next, can you break prison here with 3s? Yes, he has $3. They want $3. 3 goes into 3 once. 3 to the first comes out. 3 to the first comes out. But 5 unfortunately doesn't have enough money, so he's in. Alright, we can do one more move. You can cancel 3 and 9. Make this 3, because 3 goes into 9 3 times. So that is 4 root 5 cube over 3. Cube root 5 over 3. Okay? Any questions? Okay, now I'm going to make very challenging question next. It's not in the homework. So hard, I don't put it on homework. Can you simplify this? Wait a second, what did I just do here? I just flipped 4 and 9 and I also put this in the denominator. Yes, we can. Again, simplify means no big powers inside. Do you see a big power inside? Yes, so we can simplify. And no ratio inside. And no radical in denominator. I see a radical here, for example, in the denominator, so that needs to be taken care of. I just flipped it, and this problem is harder. First, our initial steps is the same. Break 135 into factors. What was it? 3 cubed and 5. Good. We save this guy out of prison because he has money, right? So all the steps are pretty much identical except the last part. So this 3 comes out as 3 to the first, right? And I even simplified these and get 3, right? Now let's do requirement check. Do you see any big powers inside now? Do you? I see only power of 1. No. Do you see there is only one radical? Do you see any ratio in this radical, inside this radical? This is the radical inside of, I checked inside. Here is the inside, no ratio. Great. So is this the final answer then? We never got to check this part in the previous, but no, this is radical. Do we have a radical in the denominator? Yes, we do. Now, how do I fix? How do I get rid of this radical from denominator? There is, what's that? No, we can't flip it, because when I flip a ratio, it's no longer the same. Like if you have 1 over root 2, and if I flip it 2 over 1, that's what you mean, right? Flip it. They are not the same number. Divide 1 over by root 2, I think it is 0.7. This is 1.4. They are not the same. So you can't flip a ratio, right? Like that, okay? Because it's not the same number anymore. So here is the tool you have. You can multiply both sides of the numerator and denominator with anything you wish. It's your choice, but I want you to multiply both sides with a radical which is going to get this guy enough money to break prison. Because this is the reason we have a radical here. This 5 didn't have 3 inside. I'm wondering, can you move in more prisoners that combine with 5 and make enough money, $3, so they can all break prison? What do you think you're gonna multiply both sides with? I believe it's gonna be the same type prison, same security prison, so they can combine. So you need to move in new prisoners here. They will combine with 5 to the first, and they will all break prison. Who is this question mark will be, please? This has only $1. How many more do you need?
25.
Or 5 squared? 5 squared. You need 2 more to make 3 so you can break prison. Again, these two now combine to the same prison cell, 3, 3, 5 to the first, 2 more guys make 5 cubed, and it's exactly 5 because these two cancel. $3 goes to 3, 3 over 3 is 1, 5 to the first. So this is what the result is, 3. Well, how about these? How do you multiply this? These two just come together, 3 times cube root of 5 squared over 4 times 5, look, 4 times 5, which is 20. So the result is 3 cube root of 5 squared. Actually, you can make that 5 squared into 25 now, because we are all done. When you're done, you don't have to keep things in power. You can make this 25. So cube root of 3 cube root of 25 over 20 is the answer. How did I get 20 again? I multiply 5 times 4 because when they combine, they break prison as 5. Okay? So this is a good exercise. First time we ended up with a radical in the denominator. This is how you cure it. You always figure out same type radical with a new inmate so they can combine into something reducible. Okay? Alright. This is it. This is how you simplify radicals. We'll continue with the next section tomorrow.